Right. Again, so...
Wait, so horizontal is only range, right?
Mm-hmm. Yeah, so d is the range, vx is the horizontal component of the velocity, and then time is the time of flight. And then vertical, we've got our initial vertical velocity, we have final vertical velocity, we have acceleration, we have distance, which is typically going to be what we use to find our max height. And then we also have time of flight. All right, so these are our variables that we'll have for our horizontal and vertical projectile motion problems.
Wait, what's that above the D?
Max height.
Max height.
A equals max height, right?
No, D.
D equals max.
Then why did you put it above?
I didn't. I put
What is the A equal acceleration?
Acceleration. And what is acceleration always equal to for these?
Negative 9.
-9.8 meters per second squared.
What is the Vx equal on?
That is our horizontal velocity component.
So vertical, initial vertical velocity?
Mm-hmm. Yeah, so we have initial vertical velocity, initial final velocity, acceleration, d, which we'll use to find max height, and time.
These will always be here? For all of
Now, you may not, like, those are the only possibilities. You may not have a value for those, but these are the only, like, options that you'll ever have.
Will you always have all of the answers for all of them, except for, like, the ones you're trying to find?
For the most part, yes. And, like, it's not going to give you acceleration because you know that. And we know that, remember, time is always going to be the same on both sides. That's what lets us, like, link the two together.
So, when we are done with this problem, we will know what all of those equal.
Yes.
Okay.
Because it's asking us to find the time of flight, the range, the maximum height, and the final velocity. So, the first thing, right, we know we need to do is we need to take our initial velocity and split it up into those components. Okay? So, I'm going to, like, shrink this down. That way I have room to, like, work stuff out. Okay? I'm going to put it over there. So, remember that to find the horizontal component, it is your initial velocity times cosine theta. Right, so that's always going to be true. So we know that in this case, our horizontal velocity component is going to be 11.3 times cosine of 35.
Are we solving for this? What are we solving for the thingy up top?
We're solving technically for this.
Yeah, that.
That's Vx, and then this is VIY.
No, I just was curious if we were solving, like, if the math that we were mathing from was on the little triangle.
Oh, yes, it is. Sorry.
Sorry, I really did. That was weird. I think to ask, but I didn't know how to ask it.
Okay, but we're on the same page now. That's what matters. So then 11.3 times the cosine of 35. When you multiply that together, you get 9.26 meters per second.
So, Vx.
You'll still see that.
So horizontal velocity is 9.26.
Yes, so our horizontal velocity is 9.26 meters per second.
So you have to solve which ones you can using formulas that have numbers that you already know.
Yes.
Is it kind of like the last section where you had to use what you had to find?
Yeah, so it's really, we're just kind of like using what we learned with one-dimensional kinematics and like applying it to this in two directions. So it's not necessarily anything new, we just have to think about things moving in a different way. So now we need to also find our vertical velocity component.
Vertical.
Initial, right.
Will we need that little card in this section?
Hmm?
Will we need the little card in this section?
Yes.
The little blue one?
Mm-hmm. We'll use that more for the vertical part.
Okay.
All right, so then to find VIY, it's VI times sine theta. So in this case, that will be 11.3 times sine of 35 degrees. And that would equal 6.48 meters per second.
What is sine equal?
What?
Like, what is sine equal?
Opposite over hypotenuse
What is opposite over hypotenuse?
of this right triangle we have up here. It's a ratio of sides of a right triangle. Okay, so now we don't really have enough information to solve for anything on the left side yet, because we only have one variable, or the horizontal side. So let's look at what we can about the vertical side. So I'm going to increase the size of this. Oh, man. I didn't keep that. So this soccer ball, right, is like, it's kicked at that angle, but then it's going. So since we're trying to find the time of the total flight, we're gonna say that at that moment d is equal to 0. And then we need,
How do we get d equals 0?
because we're talking vertically. So since it's on the ground at the end of its path,
Oh, yeah, okay.
its vertical height is 0. So then now we're going to use one of our equations of kinematics that we have, like one from your blue card.
I don't know where my blue card is. I saw it like 5 minutes ago, but it's gone now.
Is it under your binder or like stuck in a page?
No, it's in the loops.
I don't know. All right, so we're trying to find t, right? If we're trying to find time and we have initial velocity, acceleration, and distance, what equation would we use?
Wait, what is it?
All right, so we need to find an equation from our card that will allow us to solve for time. So it needs to have time, distance, acceleration, and initial velocity.
So the third one?
The third one.
Yeah.
So that third equation is,
D, initial velocity, the time.
so D equals VIT plus 1/2 AT squared. Yes.
Wait a second, you said distance. How far, like, what do you mean the distance?
Vertical distance.
So
So D. Like, so the one, we're on the vertical side. So here, we're talking about it we're trying to solve for time when the vertical distance is 0.
Okay. So,
Okay. So now we're going to plug in the values that we know. So d is 0. Vi is going to be our VIY, which is 6.48 times t plus 1/2 times negative 9.8 times t squared. So then 1/2 times negative 9.8 is negative 4.9. So now we have this equation here. So we have 0 equals 6.48t minus 4.9t squared. What kind of equation is that?
algebra.
Quadratic.
Yes, it's a quadratic equation, which is, yeah, algebra. But it makes sense though, right? Because this is a parabola. So we're going to get two solutions because our distance, or like our time would be equal to 0. Well, no, let me think about it this way. We get two solutions.
Once you get to the top. After.
Well, it doesn't change, but like, so distance is 0 at two places, at the very beginning and at the very end. So it makes sense that we're going to be able to find the time at this. We're finding the time technically at the very beginning, which is going to end up being 0, and at the end.
The other time is going to be when it ends.
Yeah, it's going to be the one that we need. So what we can do now is we can factor this, right? They both have a t in common, right? We've got a t and then a t squared. So if we'll pull out the common factor of t. And then we have 6.48 minus 4.9t. And I'm just putting my equal 0 at the end. So then now we're technically setting both of these factors equal to 0.
Yes.
So then we get t equals 0, and we get 6.48 minus 4.9t equal to 0. And then so the first one we don't really need to do anything with because we know that at time 0, the distance is 0. But we need to find the other time. So we're just going to subtract the 6.48 over. And then we get negative 4.9t is equal to negative 6.48. And then we're going to divide by negative 4.9.
What happened to the t's?
It's still there. It's right here. Negative 4.9t. And so that gives us 1.32 seconds. So I'm going to go ahead and write that.
What?
1.32 seconds. I don't have room under there to divide it. So that's our total time of flight. Yeah.
So what if time
1.32.
Time equals 0 and 1.32?
Huh? Yes. Because we found the two times when the ball is on the ground. So it's on the ground like right before it leaves the ground. And then once it goes up and down and comes back down. Alright. So now we have to find, let's see. So we have found the time of flight. And we need to now find the
initial vertical velocity.
And we need to find the range, so our horizontal distance. So the horizontal distance is easy to find. I'm going to shrink these. I like that I can make stuff small and leave it there. So for horizontal distance, you're always going to use velocity as distance over time. That's the only equation you're ever going to need to find anything in the horizontal side. Is v equals d over t. So we know our horizontal distance is 9.26. And we are trying to find distance, so trying to find our range. over 1.32. So we'll multiply both sides by 1.32. So that cancels there, and then we're going to multiply those together to get D is equal to 12.25 meters.
What are we saying? Oh, never mind.
No, we don't.
You said it was 0.
No, we use distance as 0 to find our time of flight. We also have to use it to find our maximum height.
But the max height was 0.
No, the max. All right,
That's what you have written. You had 0 written down.
I know, because we use that to solve for our time of flight.
Oh.
But now we have to find how high off the ground it goes, which doesn't make sense if that's 0, right? Not for this type of
I
problem.
was wondering what was up.
Yeah, so now, and remember when we talked about it at its maximum height, that happens at half the time, right?
Yeah.
So half of our time is equal to what?
Half of 1.32?
Yep.
166.
Mm-hmm. So now we're going to use that as our time. Like, we're going to use that for T and plug it into our third equation again and find D.
Oh.
Did we already find D though?
No, we had D as 0 because we used that to find the time.
Hold on. What did you do in red? I'm very confused.
Okay, so when we have an object that's getting launched and goes down and back around, right, from the ground, its max height occurs halfway through, right?
Yes.
So that means it's occurring at half of the time. So, like, if the ball is in the air for 1.32 seconds, that means 0.66 seconds in is when it's reaching its maximum height. So that's why we're going to use this value for time and our third equation, so this one here, to solve for D. So we have D equals VI T plus 1/2 A T squared. And so we're going to use, we know our VIY is 6.48 times 0.66 plus 1/2 times negative 9.8 times 0.66 squared.
Can we not do anything after this problem?
Yeah, that was the plan.
Honestly, I'm getting a headache.
That was the plan.
This is not.
It's a lot, I know. So, then when you multiply all that to get, so you square your 0.66, then multiply it by everything, then add the stuff together. I'm skipping that step. It equals 2.14 meters.
And that's the maximum?
Yes, that's our max height.